So a data frame has rows and columns, and every column has a name and a data type. The name and the data type of the column consist the schema. So the schema defines the name as well as the type of each column. So if we take a look again into our data frame illustration, we can then see here that every column has a name and a data type associated with it. And these two information equal to the schema. So this is the schema. Oops, let's see what is happening here. So this is the schema of our data frame. And this looks like this. The data frame has a method called print schema that can let us inspect the current schema associated with a data frame. So it looks like this. We take our data frame and then we use print schema. This will then print out the schema of our data frame to the terminal window. Let me comment this out, build it again, and then run our app again. So here we have the current definition of the schema of our data frame. So what we have here is that Apache Spark, after reading our file, automatically determine that there are so many columns in our file, and every column is of type string because we didn't give the system any information about the file. If you take a look into our file, we can see that the first column is of type integer, the second one is of type string, and so on. So, but here everything is of type string, and the name are also not quite, how can I say, they really meant nothing. C1, C0, C1 or C2. These are automatically assigned name to the columns. So there are two ways we can solve this problem or make it better. The first one is to let Apache Spark infer the schema. This means we should tell Apache Spark to try to determine the data type of every column in our data frame. We can do this by passing an option, and the option name is infer schema. We will set it to true, and this allows Apache Spark to do an extra scan of our data, read every column, and then decide if the column is of type string, integer, boolean, or whatever is present in the file. So let us build this again and run it. So now we have a better solution. So Apache Spark has automatically determined the data type of our values in the column. So if you take a look right now, you can then see, okay, the first column is of type integer, the second one is of type string, and so on and so on. So this is okay if we just want to take a quick view into the data, or if you are just doing some ad hoc queries. But for production code, you should always specify the schema of your data frame manually. What I mean by that, for example, if you take a look at the definition of the customer data from the TPCDS, then you will see that all these integers, so columns, are identifiers. So these values are generated and they can be larger than a value that integer can hold. So with this information in mind, we then need a way to let Apache Spark knows that the first column is not of type integer but of type long, for example. And also you can see here that because our file doesn't have a header, the name of the columns are automatically assigned, which is quite hard to work with. So now we will see how we can really specify the name and the data type of a data frame. So we have our file, we set option infer schema is true. This is still better than nothing, but a far better solution is to remove this, and I'll show you how you can specify the schema. We then go there, put schema, and here you can specify the schema by using a data definition language formatted string. What is a data definition formatted string? So we know that a schema consists of a name and the data type. So a column name and the data type of the column. So we have something like that. We can say that our first column in the customer data file has the name customer as car and is of type long, for example. And then we can say the second one has the name customer ID and is of type string. And then we will build this. Of course. And we will run it again. Now there's one thing you can see here. Because we only specified the name and the data type of two columns, Apache Spark only read these two columns and also assigned them the specified name with the specified data type. And let's take a look now into so this is the specification of the customer table, and as you can see, it has roughly 18 columns, all with different name and different types. And I'll already create this schema manually, so let's take a look into it. I've created a file called constants, and in this file here is where I define the schema of our customer file, and it's exactly the same. I used the same name as we have here in the definition of the file. So now that we have a schema, I'm going to apply this to our read method so that it will read the file, assign the correct name to the correct let's say columns, and with the real data type. So how do we do this? So here, instead of passing in a string like that, we can just do this. So customer schema, build it, and we can also, after printing the schema, display the file's first rows. Now, because we have specified all the columns, the schema will also contain everything. So now you can see here that Apache Spark now has the real name for every column, and the data type is also the right one. And here you then have a small list, an except of the first 5 rows available in the file. So you can see that I guess the first customer has a last or first name, Lewis. Here you have it. So this is how you can specify the schema of a data frame. So by reading files, you can either let Apache Spark infer the schema automatically by using the option infer schema, setting it to true, or by passing in a string that defines names and data type of all the columns. That way you can be sure that you will not end up doing division with strings and stuff like that, because as we saw earlier, you cannot tell what of this here is a real string or which one is a number. That's why always specify the schema manually.